So what is clustering? Clustering is a way to split the data into groups, right? So there's this lump um, of objects of anything. Like we all do clustering all the time, right? Um, because when we even name objects, those objects are not the same. Like when we say a tree, um, kind of identify a cluster with a name, but what does that name mean? Does it mean everything in this cluster is the same? And yes and no, sort of. Some trees are more similar than others, but there is definitely a huge um, diversity among what we call a tree. Clustering is also a compression mechanism. If we have identified and agreed on clustering in the data, then all we need to say is a tree, and it's already clear what we mean. We don't need to discuss the whole diversity and details in the scenery when giving instructions or communicating. So clustering is a way to discover regularities in data, but you can think of it as a first sort of step to classification, because classification in a way is assigning observations to clusters. So the only definitive difference is that clustering is unsupervised. What we're gonna see in this lecture, or what you may have already seen with mixture modeling, that clustering actually is a way of mixture modeling. And let's see how we usually define the clustering. So what is it sort of formally? So it's very similar to mixture models. Which component does X belong to? Which cluster? The process of grouping objects into clusters by similarity, right? We put similar objects into the same clusters. We want have similarity within the clusters to be very high. We want a subject inside of the cluster, objects, I mean, inside of the clusters to be very similar or highly similar, and we want objects across the clusters or samples across the clusters to be dissimilar. So clustering is the most common form of unsupervised learning, as they say. But although, just I have to make this note, we've talked about PCA, ICA, NMF, kernel density estimation, and so on. Those are also unsupervised method, and they're much more like very commonly used, even in clustering as an unsupervised technique, and within the supervised world as well. But still, when you say machine learning can be split into supervised and unsupervised, which is already um, not fully correct picture, but we often do say this, um, roughly split into the two components, although there are other components, just so you know, other components to machine learning. But when we say unsupervised, usually it's like, what is unsupervised? If supervised is classification, then unsupervised must be clustering. So, but the problem is that clustering is subjective. You can cluster objects many possible ways, and they all will be sort of correct. For example, let's look at the Simpsons family and the Friends. Like we can extract multiple groupings. We can extract the grouping of Simpsons family, or school employees, or females, or males. And as you see, in the group of females and school employees, same people can make it into both groups and into ma many groups. So it's kind of subjective of how you define those groups or how you uh, like choose which groups to split the objects into, because um, some of the group classes or like group sets, they could admit sort of conflicting assignment, or you could equally well put the same person from the or character from The Simpsons to many groups, and which one will be correct is impossible to say because, well, depends. Another one is, what is similarity, right? We want highly similar object within the same cluster, and we want uh, dissimilar object with different in different clusters. But similarity is hard to define. Of course, we know when we see it, but it's very hard to pinpoint.